Thanks. Thank you, everyone, to be here. Please make silence in the bar, in the back of the main room, please, in the exhibition part. This is now the tech talk for today, Thursday. I would like to give a special thanks to our jury. The jury will be following online and on site the tech talks with our jury chairman, Mr. Jérémy Lagarrigue, Mr. Marco Casiraghi from Yacht Club de Monaco, Mr. Florestan Fillon from the Prince Albert II Foundation, Mr. Ricardo Corzani, Credit Suisse, Mr. Erwan Lebel, Espen Oino, Mr. Alex Kazerg from Sirocco, Mr. Martin Gégère, EODEV, Mr. Julien Hélène, Alternative Energies, Mr. Abdullah Nahar, YPA, Mr. Louis Le Goff, ICOS, Dr. Raffaele Chiuli for UIM, Mr. Mauro Ricci, ACA, and now we will start with the first tech talk, not on stage. Please make silence here in the room. Please make silence because we are online. Respect the speakers, respect the jury members, and then I call online the first team, DB20, Dutch team, for the solar class. Can you hear us? We are listening to you, we are watching you. DB20 solar boat racing. You have 7 minutes.
Can you hear me? Hello? Can you hear me?
We are listening to you. Monaco is listening to you. That's your turn.
Yeah, but can you hear me? Yes or no?
See you, we don't see you, but we are listening to you. Yes.
Yeah, but you hear me? Okay, so, you hear me?
Yes, almost, because you have the sun behind you, but it's okay.
Okay, good afternoon here from the Netherlands. I'm Wits de Vries and I'm going to, here's the tech talk on behalf of the DB20 solo boat team. With the DB20 solo boat team, sadly we couldn't make it this year, but we would like to tell you something more about the things we did last year, and hopefully we can be there next year. So we are founded.
Please, sorry. Be quiet in the room, in the bar, and the exhibition part. Respect the speaker. Please make silence here in the room. We are listening to you, DB20 team.
So we were founded in 2015. We started in a young solar class. After this, we built a V20 solar boat. We consist out of 6 team members from different backgrounds. And in 2018, we became a world champion in the V20 class. Our boat is a V20 class boat. It weighs 200 kilos. It's 100% made out of carbon fiber. Our solar array has an area of 9.2 square meters. We have a top speed of 35 kilometers an hour, a battery of 1750 watt hours, and 6 kilowatt drivetrain. And with our hydrophiles, we can sail much more efficiently. We compete in the Solar Split 1 challenge and in the Monaco Solo Boat Challenge, but yeah, sadly this year we couldn't make it. Further, we do demonstrations in different places. So there we like to show people what we can do with the clean energy. So for the last year, we've been working on a drivetrain, carbon fiber propellers, and a modular sensor platform with which we can better understand what the boat is doing, and with this data we can better we can make smarter decisions on which part we can change. And the last thing we've been working on is load measuring in composite parts. So I can talk on all these topics for quite a while, but for quite a bit. But for this tech talk, I want to focus on the development of the carbon fiber propeller. So we the carbon fiber development is built up out of 3 phases. Firstly, we have the hydrodynamic design, the mechanical design, and the manufacturing. And so the hydrodynamic design, we designed the propellers with a custom script in Python, and in this custom script we use the open prop solver. We rewritten it to Python because natively it's a MATLAB script, and with this script we can build the load distribution of the propeller, and with Xfile, which is a tool to calculate what the forces are on what the characteristics of the airfoil are. We can see what airfoil has the best characteristics for certain parts of the propeller. So for the mechanical design, we looked at different possibilities. So build it out of one piece, make it disassemblable, and make it in different parts and then glue it together. In the end, we chose for the gluing together part because this made the production the easiest and most efficient. So we produce the propellers with 3D printed molds. So we use the simple PLA FEM printed molds, which makes them really cheap and really accessible and really quick to make. The downside is that they're not capable of withstanding high temperatures, so we can't use traditional pre-preg materials. Therefore, we use our own wet impregnated laminate. So we have dry fibers, and then we impregnated it with resin, and then we in that way we still have quite a good control over the amount of resin in the laminate, and then we press it between these molds. In the mold, here we see a cross section of the mold, and here we see the airfoil shape, and on the leading and trailing edge you can see chambers where excess resin can go to during the pressing of the 2 mold halves. And furthermore, this mold design is self-aligning, which makes clamping a lot easier than normal molds. And because we found that it's quite annoying to draw these complex shapes in normal CAD systems, we built our own script in Python, which can directly model these molds and then export it to a 3D file. And this really streamlines the production of the propellers. So then the composite layup was also a challenge. Normally with composite hydrofoils, the laminate is built by slicing up the hydrofoil. But in the case of a propeller, we found that these shapes are really tedious and really small and difficult to cut with scissors. and it's quite difficult to calculate because the blade is twisted, and therefore we looked at different ways. We use the unidirectional fibers, and we found that we can squish them between the molds like this. So this makes the calculation of the laminate really easy, because there you can now just put a blob of laminate in between there. You only have to know what the volume is, and therefore you can really streamline the production. And the hub design, we made such that we can put different blade angles in there. And that makes it possible to just make a bunch of hubs and then glue different blades on top of it. This also makes the production a lot easier and quicker. This is our
less
current.
than 1 minute for you.
Yes. So this is our current iteration. So we still have some things to improve. So, for example, the hub connection. But this is our first iteration. We did this in 2018, and this was still really basic. But in October 2020, we were able to first sail with one propeller, and after this, we started to optimizing. Not all props survived the test, but this is how we got to this point. I would like to thank you for your attention, and I want to wish all the teams in Monaco the best of luck during the race. And if there are questions, I am here to answer them. Thank you.
Applause here in Monaco. Jury members, do you have any questions? We'll give you a microphone for DB20.
Thank you for your presentation, and especially for taking the time to do the tech talks while you cannot join due to the coronavirus situation. I was wondering, you say that the design was directly coming from the result of Python, which we understood, but I am more interested about the optimization behind Python. So what was your main objective? Was it to look for the best efficiency? Was it looking for the fastest speed? What was, let's say, the goal by the optimization calculation you had behind the Python codification?
So we have the Python script, and with this Python script, we can generate the most efficient propeller for a certain boat speed and thrust level, and with a certain RPM of the propeller. So it's mainly focused on efficiency, and we can then just put in a number of input variables, to really optimize the propeller for those input variables.
Thank you. Do we have other question?
Is there any question here in the room? No.
Thank you.
Applause again for DB20. Thanks DB20. I call on stage another huge team, but this is not Solar class, this is OpenSea class. Please come and applaud TU Delft OpenSea class project. Multi-hulls, hydrogen and hydrofoils. Gerben, we give you a microphone and you have 7 minutes for your presentation.
Thank you very much, Maxime. First of all, we would like to start by thanking the organization of this race and the Yacht Club for this incredible opportunity, the hosting of this event, and the chance for us to present to you our boat. Can I have a clicker? Is there a clicker? Yeah, for the slides. Get it. So what we did is with our team build the first ever hydrofoiling hydrogen boat in the world. Here you can see it, flying above the waves in the Netherlands. We are the TU Delft Solar Boat team, and we come from the Netherlands. Here, another picture of testing. This was during our very first hydrofoiling test in the Netherlands. And today, we have made the first flying test in Monaco as well. Well, when we take a look at the Netherlands, we of course see a rich maritime history. And also the home of various yacht builders. For example, the famous Fed Ship and Wire Yachts, which are both partners of our project. We come from Delft University of Technology, one of the top 20 engineering universities worldwide. We come from the TU Delft Solar Boat team. And this is of course perhaps a bit of an old name, as we are building a hydrogen boat. This is because we have 15 years experience in building solar boats. We've participated in the Monaco Energy Boat Challenge multiple times. And this year we've made the next step. With this, we are the only student team competing in the open sea class. And a last point that I would like to mention is that we are one of the few teams in Delft that have support from the university with a so-called dream team status. This is our team, divided into multiple departments. But let's get a bit into the boat. Rick.
So for our project, we had two main inspiration factors. And as Germen said, we originated from building solar boats. And one of these boats, the solar boat of 2019, really inspired us because there was a hell of a project to build, building 3 hulls within 1 year. This boat also competed in the open sea class, and they won the endurance race in 2019. And besides our 2019 solar boat, we were also amazed by the AC-72s, which were used in the America's Cup with its, well, very remarkable L-shaped foils. So, if you take a top view at our current boat, then we built a hydrofoiling trimaran, which is powered, which also powered by hydrogen. It's around 8 meters long and 6 meters wide, and has a cruising speed of 18 knots. And we convert the energy, which is all stored in hydrogen, with a 30 kilowatt fuel cell. So its jar weight is around 900 kilos. And at maximum, if we fill our tank completely, we can take 8.4 kilograms of hydrogen with us, which is then stored on a 350 bars.
Well, so how did we come up with this design? Or where did we optimize it on? Well, we started by refitting our 2019 hulls. So the picture I showed you, it may look familiar, because it's exactly the hulls from the award-winning 2019 boat. What we did is remove the solar panels, install a hydrogen installation, and attach L-shaped foils to this boat. All these foils are actuatable to ensure stable flight above the water. During our design, we have optimized on many points. For example, we have optimized on strength with finite element modeling. We've optimized our foils, we optimized our propeller with the famous Marin database, where many propellers are available with all the data on efficiency. We have also analyzed the behavior of our foils with a digital twin in the form of a state space model. With this, we can analyze how our boat behaves in the waves and ensures the different impacts.
So one of our focus points of our boat was to be as lightweight as possible. And therefore we predominantly used 2 types of materials, namely carbon fiber and aluminium. And just as in every production phase of a project or a vessel, we also did encounter some problems. Well, and the first one being that it was our first ever hydrogen vessel. So we had to obtain new knowledge from all different sides and really dive deep into new material in which we didn't have any experience yet. And another thing that also made things pretty tight and pretty hectic were the lead times in the hydrogen sector, because they were longer than we expected. And as we only had 4 months of production time, this all made our schedule really, really tight.
So when we built our boat, we of course had to test it. We started this in the port of Rotterdam, where you see a picture of in the left top. We started out without the hydrofoils. We started analyzing how the boat behaves without the foils and only on the hull drag. With this, we gathered data points that are plotted in orange. Afterwards, we attached the foils and gathered new data that's plotted in green. As you can see, there's quite a reduction. At our cruising speed of around 15 knots, we see a reduction of 50% of the required power to sail. With this data, we also validated our engineering models and see where we can improve this for next years. Another statistic of our boat is that its top speed is more than 20 knots. This is the highest that we've sailed since yet. And we've made some really good test runs. We had a test run of more than 3 hours of foiling with less than 10% downtime. But of course, an important part of building a sustainable boat is a life cycle assessment. Here, you see our LCA. Of course, we start the production of a new boat with new components. And there's a waste stream. For example, the consumables used in the producing of composite parts. After this, we test our systems, we race it, we sail it, and there's another waste stream. There are parts that we unfortunately cannot reuse. But there's also a great part that has found a new purpose. For example, in a new boat or in demonstrative purposes. This can be, for example, in exhibitions, fairs, or museums, like we have did with our previous boats.
Yeah, so for our eco-design, eco-friendly design, we mainly had 2 focus points: using eco-friendly or green energy, and the second one, using that energy as efficient as possible. So we only sail on green hydrogen, which we obtain from refueling stations in the Netherlands, and we use lithium iron phosphate battery packs, which are more eco-friendly than your conventional battery packs. Besides, yeah, well, that's the eco-friendly energy use. And with our efficient energy use, for instance, we use hydrofoils, which lift us out of the water and immensely reduce our drag. And we focused a lot on the propeller design, and this gave us the opportunity to reach a propeller efficiency of 77%. And so for our own innovations, these are the points in which we think we innovated the most. Well, first of all, we switched to hydrogen, which was completely new for us. So this really took a lot of steps. We still use batteries though, but that's for peak shaving. So when we suddenly need an enormous amount of power, the batteries can provide this. And this year is also the first year in which we have multiple open loop cooling systems. So we have 2 open loops and 3 closed loops for cooling all our components. And well, the most mesmerizing part of the whole boat, I think, the actuatable hydrofoils, which lifted us out of the water.
Thank you very much. And then the last slide, of course, what is the purpose of this project? How is this relevant? We think this is an amazing opportunity to have a third option in ferries. There are also players in the maritime sector already researching this option. And we think it's very interesting due to the comfort of the hydrofoils, the sustainability of the hydrogen, and of course also the general idea of sustainable travel. This can be marketed as a third option, next to the classic ferries, the high-speed ferries, and a new luxury, eco-friendly method of maritime transport. Thank you for your attention. We'd now like to take questions.
Applause for you. Jury members, have you any questions? I think you have.
No, I have to say that when we wrote the rules with Marco, we had the idea about this boat, and you did it, so thank you for that. That's the first point. Maybe yes, it is important that you share the experience you had, because I'm sure that it was not that easy to achieve in such short period of time, and also during the coronavirus. You just highlight that you had some trouble by the supply of the H2 suppliers that was, I can imagine, longer than the other one. But also, can you share a bit more in the details, let's say, the point that was the hardest for you to achieve in order to have the boat which is already here in Monaco?
Could you repeat your question, please? It was a little bit difficult to hear from here.
Okay, what was the hardest point for you to have the boat on the water, and what do you learn the more by having this open sea class compared to the solar class?
What is different compared to the solar class is that, everything just gets a lot heavier, and it becomes more of a kind of a logistical challenge to also build a bigger boat, but also safety-wise. At the solar boats, it's a pretty low voltage which is used to power the motor, and within our boat it's 400 volts. So, also compared to solar boats, it's not as easy to fix as it has to stay in the water. So all components that we have, they just have to work and they cannot break down. So also changing from all your parts which you design and which you engineer, they become a little bit more robust and a little less, less easy to break. And I think that is for us the biggest change or the biggest difference in solar boats versus our current open sea class boat.
Okay, and now maybe we can go into the technical details, or maybe the jury have some question.
So now you are running H2 compared to last year, or 2 years ago. So what are the main difference on your energy management compared to solar panel? You talk about HV instead of low voltage. So how do you manage the energy between the hydrogen, the batteries, and how does that work concretely on your boat?
Yeah, from our fuel cell, that is connected to a DC-DC converter, which converts the energy from the fuel cell so that it can go on the 400 volt bus. And we have our own, our fuel cell engineer has written an algorithm in which actually states how the fuel cell should work in combination with the batteries. And we mainly focused on the point that the fuel cell constantly delivers all the power and that the batteries only act as a buffer in case it is needed. And so what we see during sailing is that we almost use no energy from the batteries and that we're actually fully sailing on the fuel cell.
Thank you.
Another technical question from jury member.
Yeah, just wanted to ask you one more question. What was the overall weight of the whole system, batteries and hydrogen tanks and...
The overall weight of the boat?
No, not the system, the package.
Of the hydrogen system? Well, it's a bit difficult to say because it depends on what you account to your electrical system and what you account to your hydrogen system. But if we see our hydrogen system as the fuel cell, the DC-DC converter and the tank, then the complete system weighs around 230 kilos for hydrogen. So that's the tank, that's the DC-DC converter and the fuel cell.
Okay. Thank you.
And so also you look like that you wanted to fly because you take the experience from the America's Cup. We know that they have a L shape due to the fact that they have the wind and they are sliding on the water. And I was a bit surprised when I did not see that you made a T-foil because it will be easier for you to build and cheaper. So what did you choose this direction?
Yeah, I think this is a very interesting question because indeed L-foils are way harder to produce and they're also way harder to actuate. But the thing that we have is, well, our pilot only now sailed for a month in this boat. And every year we have a new pilot. And the problem with T-foils is that they would stick out of the side of the boat. And with the sailing skills we actually got, there will be a very big chance of us actually destroying our own T-foil by just sailing it into the quay or hitting any side object.
Thank you. And last, by the flying stabilization, from what we have seen so far, we were speaking with Alexandre, it looked like you just manage the stability from the rudder with the pitch on that side, or are you also changing the pitch and the rake of the main foils?
Yeah, we're actually constantly changing all of them. So we have three main, how do you say that? Flight variables. We have got our height, so that's actually the height of the boat. Then we have the roll, so the rolling of your boat, and the pitch. And they're all constantly, we're all constantly trying to sail as stably as possible with our control algorithm. So, and that control algorithm controls the roll, it controls our height, and it controls our pitch of the boat. And the pitch of the boat is a combination of the front foils and the back foil. The roll is a combination of the left and the right front foil. And the height is actually done by only the front foils.
And have you considered using the IE in order to have a sort of lesson learned from all the sailing that you are in order to improve the flight control?
Yes, we indeed have. And that's because we have used the same height control algorithm as the team of 2020 used. And they're also here this year. So we actually build up on their knowledge and their experience with flying a three-strut or a boat with 3 hydrofoils, and applied that same model as it was successful to our own boat, but then with some different variables.
Thank you. Congratulations.
Thanks a lot.
Thanks a lot to you, Delft Dutch team, and we stay on the open sea class because now I call on the stage Vita Yacht, please, from Monaco. Applause for them. You have 7, 8, 9 minutes, not more. Please, what's your turn?
Okay. Hi there. I'm Stuart Wilkinson, chairman of Vita Yachts. This is Ryan, who's in charge, our lead electrical engineer. Okay, let's go for the... we're from Monaco and the UK. This is the Lion, which we've got here now. It's our latest production boat, 10.5 meter, 235 kilowatt hour battery boat that's aiming to replicate the sort of dayboat like a Riva. We have about 20 people in our team now. We're based down here in Southampton. This is a team in Southampton when we tested the Lion and launched the Lion about 3 weeks ago. So far, testing is going well. The team consists of electrical engineers, software programmers, some people in the marketing department, and we also have a team focused on fast charging. We have another business now called Aqua, which we've rebranded our charging network to Aqua, and we're building the first global marine charging network for boats. And we've had someone from the charging industry, auto charging industry, to do that. Can I have the next one? Is that the next one? Yeah, okay. Good. This is, we've come here for, I think, 4 years now. That's a drawing of the first boat we came here to race with. I think it originally won the speed race, but I don't know if there was anyone else competing against us at the time. So, but over time, we've really enjoyed participating in this competition. Our boats are all driven by our own powertrain that we build in-house. We create all our own software, have our own proprietary control system, As I said before, we're very, very focused on charging because we're very, we see that as a key challenge, getting the charging time as short as possible to replicate the charging, the refueling time on a normal boat. So what's driving us? We are building an efficient hull, but we're not using foiling. We're trying to build a regular boat that can be electric. So that's very much where we're coming from. Someone can recognize the boat. Okay, this looks like a regular day boat. And we're doing the same in ribs now. I'll go into this later on. But this is the one we have here is a day. We have two boats here, actually, a day boat and then also a boat that has our powertrain in that's been built by Tenderworks to test the powertrain for a super yacht tender. What do we make the boats out of? Carbon fiber. It's getting more widely recyclable, so we're keen on that. So far, we found that's the best material for the hulls of these boats. When we build the rib, we're going to go into building it in aluminium. What was the problem we supplied? Well, the boat market's on fire, so getting parts has been a major problem for us, getting propellers, steering actuators, all the actual boat parts of it have been a big problem in the supply chain, partly because of COVID and partly because the boat market is really, really going well at the moment. Okay. It took us 18 months to build, I think mainly because of COVID. We think it takes about 9 months to build this boat going forward. I'll take this right, I can do it. Where we are now is we're testing the boat along from here between Cannes, Saint-Tropez and Ventimiglia, and here where we have chargers. The boat, we're going to put the boat with Hotel Martinez for a bit, see what they do. We're trying to build up an extensive sort of database of what people do on boats of this type. Because it's a big thing, oh, we need range, but what do you actually need range for? Most people go on a boat for an hour to go somewhere. They don't actually need as much range as they think. The less range they need, the less power we need to put on the boat, the cheaper the price, etc. As I mentioned before, carbon fiber is the main part of this boat. It also has recycled aluminium on it. We have a partnership with Norsk Hydro for using their Circle recycled aluminium on this boat and on the rib, which is an all aluminium structure. Okay. You got that? Sorry, wait, you giving me? We did some. This is just an interesting calculation. Why are we building this sort of boat? Because it pollutes more than anything else. So when you go out on a boat like Arriva Rama for the day, you leave about a ton of CO2 in the atmosphere. So obviously that's a big target to go for, and that's what we're targeting with this boat. What have we innovated? Do you want to talk to this for a minute, Ryan?
So some key innovations we're working on are optimized control of the thermal system to minimize energy consumption. Minimize energy consumption of any auxiliary systems, preserving more battery capacity for range. There's not much point in having an efficient hull if we're then wasting energy on auxiliary systems. As well, focusing on looking at optimizing the cooling system to remove most parts, minimizing pumps and heat exchangers and piping through intelligent system design. And extensive data collection. So at the moment we're focusing on just collecting vast amounts of data to feed into our engineering program to make sure that we can improve on every element of the system on the next design. And focusing on, as one example of that, some modular, cost-effective battery modules to enable maximum flexibility into the types of boats we can install our powertrains. Obviously, boats don't necessarily have a regular size block large enough to accommodate the kind of capacity that most users might want. So by creating the right size module, we can we can be most flexible in terms of installation of powertrains into as many boats as possible.
Yeah, so industrialization, as I mentioned earlier, we're wanting to start at the top end of the market, build the electrical equivalent of a Riva or a Wire, and work down to ribs. What Ryan was talking about earlier on, we're calling the surfboard. So the surfboard concept is a modular powertrain that can be fitted into any boat. It'll start with our boats, and then we rolled out to other people's boats when we have got the right size batteries. We have an exclusive arrangement with Romeo Power, who are developing one of the highest energy density batteries in the world today. The range we have at the moment of boats is the Lion, which is the white one, and which is the production version of the red one you'll see out there. The Seal, which will be here in a couple of weeks' time, which is a 7-meter rib, and the Cub, which is an electric jet ski, which we'll be bringing out later on this year. Any questions?
Applause before the questions for Vita Yachts. Have you any questions for jury members?
Very well done. I have a question. Did you face any regulative challenges? Did you face any regulation or regulative challenges?
Yeah, it's something we're very focused on. In creating a powertrain that's going to be on a tender for a super yacht, we probably are at the forefront of that because we're facing all of the regulatory requirements of the super yacht to bring the battery power system on board. The main focus of everyone is thermal management and making sure you have the right sort of ventilation to deal with thermal management issues. So, yeah, that's, in a way, we're kind of developing the regulation as we're going along because there isn't very tight regulation for electric boats at the moment. So, yeah, that's where we are.
Thank you again, Stuart. And just wondering where you guys at in terms of raw material research and sourcing, in terms of more eco-friendly solutions you can get in there. Yeah, just a question on that.
Yeah. The seal, the rib we're going to bring out later on is going to be made entirely from recycled aluminium. So that's, we're moving towards there. We're going to explore whether we can make the Lion in recycled aluminium, but probably will be a carbon fiber hull. Carbon fiber is recyclable, but only one time over, you know, because it has to be chopped up in pieces and then it's not so good and all that stuff. So over in terms of what we're putting on the deck of that boat, we don't use teak, we use S-Tech, which is moving in that direction. Again, that has recycled aluminium on. But so our main sort of, and then the superchargers, like we have here, we have exclusive agreements with the people who are building them for us. When they're marinizing them, they're going to use recycled aluminium to clad them. So I guess recycled aluminium is our main angle on that one.
Thank you. I may have one other question. First of all, congratulations for what you have done and achieved. Is very, very good.
Thank you.
And you're right, because the electric boat is the most efficient, and we have made a presentation this morning showing that. But in a way, we need to anticipate for the future, and sorry, as jury, we need to ask the strong question. Do you know how many hours you need to use your boat before having a CO2 emission life cycle better than a normal boat using diesel or standard fuel?
So how many hours until it's more efficient? Sorry, just understand.
Now, in how many hours usage you will have a better CO2 impact by using an electric boat compared to a diesel boat?
Yeah, I mean, for now we only have the car market to guide us on that one to some extent. I think that in the car market it's between 1 to 5 years, depending what sort of car you have. Our feeling is it will take a little bit longer, so it might be, I would say, 2 to 6 years on our boats, depending on use. Commercial boats will pay out very well. Recreational boats, you know, it's only weekends, so it's going to take longer. So that's what we're seeing on that one.
Okay, and the last, because that was connected to the first question, we are very depending on the lifetime of the batteries. So I'm sure you are working on that from what I understood in order to optimize that. Do you have, what kind of warranty are you offering? And lifetime are you announcing to potential customers?
Yeah, they have 8-year warranty from the cells upwards. So all batteries are 8-year warranty. We believe, partly because of it depends on the use case. In commercial, I think it'll trigger it earlier. In recreational, we're telling people these batteries will last at least 15 years. So, okay.
Thank you. Congratulations.
Okay. Thank you.
Vita, huge thanks for your tech talk. Now, I call on the stage Swiss Solar Team, and your applause. So, Sebastian, you have 7 minutes, and you finished second today. We gave the result of the Calefing Labs. Then you have 7 minutes to present your project of the PRAO.
Okay, hi everyone. So I'm Sebastian, the technical director of the Swiss Solar Boat team. And first, I want to congratulate the organization. It's a real pleasure for us to be here and to be in a domain where innovation are at the center. Speaking of innovation, I want to congratulate the other teams as well. Your boats are amazing, and we are really, really hoped that you are satisfied with your result of the day. So I will present you the Swiss Solar Boat project, which has been found approximately 2.5 years ago. So about the country, Switzerland is a small island at the middle of Europe with tasty cheeses and chocolates. And our university is EPFL, which is one of the best engineering schools in Switzerland. And as you can see, we have a nice playground with a lemon lake on which we are testing our boat every week. About the team now, so we are approximately 70 students in the team. There are also both bachelor and master students with credited or only in freelance. One of the challenges of our team is that we have a real changement. So each semester the team changes and the formation of the new team members are at the center of preoccupation. The profiles are very diverse in our team with mechanical engineer, material science, electrical and microengineering, with some software engineers as well. And we are working with another school for the communication materials, so the HEIGEVO. Now, just before to present you our famous PROA, I want just to tell you about the genesis of such project. So before the Monaco Solar Energy Boat Challenge, we took part during 6 years in the hydro contest project. One of our boat was a foiling, a bifoiler actually. So we had the opportunity to work on active control since many years. And with our solar boat, we wanted to increase the stability of the boat with the multi-hulls design. In comparison with a catamaran, PROA is less wide, and we have the stability of the roll and the pitch stability. So in order to design properly a boat and to have the best boat possible, we have developed a smaller model approximately 2 years ago that you can see up on the left of the screen. So this is a crash model. In order to guarantee the best control, we have tested the systems and validated on the baby. And then when we moved on the big one, we had the opportunity to optimize the shape of the hulls and the control during the flight mode. Concerning our conception methods, so we had 5 main focuses. The first one is the speed, and then the efficiency, the environmental footprint, the reliability, and finally, the most important, the pilot safety. This is why we have made some choices, and our iterative design and validation process was first to design, then validate it theoretically, and use our experience on our smaller model to optimize in a second way the designs for the main boat. Being a team of students and being in an engineering school, one of our main concerns was to control and reduce our ecological footprints. Okay, we are building an asymmetric boat which requires some molds to produce the parts, but what can we do about maybe our main hull to reduce our footprints? One of the first conclusions is that a huge amount of carbon goes into the mold. So we have designed our main hull to be symmetric front, rear, left and right, and up and down. So we only had to use 1/4 mold to produce the 4 parts, and then assemble the different parts to have the 7 meters length hull that you have seen today on our red boat. This design, this technique, has allowed us to spare approximately 45% of the impact of the whole boat. Other initiatives, beside this technique of quarter mold, is that we have used some expired carbon thin ply prepreg in order to reduce, once again, the carbon footprint. And we have used several different techniques to control our consumables and our techniques. The life cycle assessments now, so we have run a complete life cycle assessment according to the ISO norm, and we have clearly identified the 2 main aspects in the carbon footprint analysis, which is the carbon fiber, which has been used for our boat, and the photovoltaic cells. Concerning the innovation, so I think that the main innovation is that we have built, at my knowledge, the first foiling proa. And we have also developed some techniques, the wave joint assembly of the thin ply prepreg complexes. So to present you the coaming and the headrest, it was made of thin ply prepreg, which has been stacked, and sandwiches. Then we have cut a little corner at the separation between the lines, and then we have, with a mold to guarantee the geometry, have applied our sheet to form the geometrical part. The wave joint assembly, excuse me, this is the auxiliary part, and the wave joint assembly is at the top. So at the corner of our main hulls, we have used these techniques to guarantee the local integrity of the structure. We have also developed a self-healing composite leading edge. So this is the part which comes at the front of our deck. So if there is an impact, you can just hit the part, and the resin will polymerize in order to repair locally the part. Considering the production, so the first thing is that we are a team of students, and all the parts, all the boat has been produced uniquely by us. So it takes a long time, approximately 1.5 years due to COVID-19, because our university has closed for approximately 6 months. And the budget which has been found by the students is approximately 200,000 francs. The problem faced is the production time, the complexity of asymmetric boat, because as I said, every mold has to be designed and produced for every part, except the main hull molds, and the component delivery time. Also, the team has courses and projects during the year, so it has to be considering in the schedule also the amount of time which is needed to be in the studies and in the Swiss Boat project. Now the testing. So as I said, we used 3 different various levels of development. The first one in the lab. So we have designed our part numerically, and then we have to take some practical values in order to perform an optimization before the final boat. So we used to test our materials, our motor and electrical systems, and our propellers. Now the systems has been identified and tested in laboratories. We can implement them on a smaller model, which can be seen here. And the system, the controls, the design, once validated, can process to the next step, so the production of our main boat. Considering now the regionalization of our project, so in EPFL we have the opportunity to work in a very industrial and innovation domain. So we really wanted to share as many topics of interest with our partners, and we wanted to have a mutual benefit between them and us. This is why we share with the CGN and Almatec the efficiency in the maritime industry, the foils for Almatec and the controls. And with some enterprises like CSM and Solar Stratos and photovoltaic immersions, we wanted to share and develop solar panels with lightweight applications. Considering now the composite process and structures, so NTPT fin play preg have been used, with also the help of Compare with the self-healing leading edge of our boat, and finally the green energy grids with Aventron and Alpic. So I'm arriving now at the end of the presentation, so I'm glad to answer your questions if you have some. Thank you very much.
And I think, yes, there is some questions.
So congratulations, of course, bravo. So asymmetric hull design is interesting topic. You talked about lightweight. My question is there any other benefits to it? And how do you see that structure as applicable potential for the marine industry and the market?
Okay, so first of all, the asymmetric design is one way of being original as well. So we wanted to show that asymmetric boat in Archimedean, okay, there is advantages, there is constraints, but with the foils, there is totally reliable. The first thing I wanted to say, in the maritime industry, the speed record has been obtained by Vestas with also a proa. And then in a civil application, once you controlled the stability of your boat and the size, and you can reduce your environmental impact with the energy you are using, the asymmetric boat is a possibility and maybe a solution.
So I have some question, but I am not fully normal because I am supportive as being part of the EPL few years ago. What is your the experience that you want to share with the team? Because you just came in this event, you participate in the hydro contest in the past. That was mainly designing and optimizing the shape of the hull. And now we are also to anticipate and consider having the optimization about the energy production with the solar cells. Mm-hmm. So, and I just learned that you finished second today for your first day of participation, which is quite amazing. So if you need to open the eyes of the other competitor, if you want to share with them your experience in order to push them in a better level, what will be your advice?
Maybe first of all, the main thing about hydro contest was the experience we obtained from this competition. After 6 years of participation, each year we have the opportunity to win some prizes, even in performance or in innovation, design or eco-conception. Our will was to evaluate. So we wanted to build a bigger team around the Swiss solar, the solar boat project. And maybe one of my advice and my thought is, don't be afraid of the challenge. Just push the innovation, push the design, push the originality of your boat, and then it can be very rewarding when at the beginning some people tells you, no, it will never be okay, be functional, and at the end they come back and they say, okay, I was wrong, your prototype is very beautiful and you can be really proud about it.
Okay, do we have other question? Maybe for the other team, I don't know. Well, congratulations, thank you.
Applause for you. Thanks, Swiss Solar Boat. And then the last tech talk with Solar Boat 20, the huge team. Please, applause for them. You confirm? You won last year the Tech Talk? Yes. So, under pressure this year.
Hello?
No, it's a joke. Yes, you have 7 minutes to present your project.
Yes. Ever since my year at Solar Boat 20 got closer to the end, I've been asking
Please
myself...
be quiet, make silence at the bar, respect the speaker.
What makes my team unique? And back home, the answer to that is simple. We build a hydrofoiling solar-powered boat. But here, that isn't so unique. Back home for us means Enschede, a city in the eastern part of the Netherlands where we have both a university as well as a University of Applied Sciences. And needless to say, we consist of 13 students with different study backgrounds. So I remember our first week at Solar Boat 20, and before even making design decisions, we started to have a look at what we want to achieve this year. And as you can see on the picture on the slides, we were of course inspired by the America's Cup boats. They're super fast, they're a racing sports team, everything we aspire to be. And on the right you can see our current boat. This year is quite unique for us, because instead of choosing to build an entirely new boat, we used the boat of previous year as a solid base for further improvements, which means we have the same 6 kilowatt custom-made pod motor, our 6 square meters of silicium panels, and the same hull. And we're a pretty small team this year, so we had to look quite with a critical view on what to change and what not. So we decided to change quite a few systems, and I want to focus here today on the battery and the foil system, because this year we decided to make foils with flaps. So after we got our ideas, we wanted to start designing, and for this we used Siemens software to model strength, heat transfer, fluid dynamics. But of course, when designing foils, this isn't enough. So we also did some theoretical CFDs, as well as a long water basin test. And as you can see on the slides, this is the water flow past our hydrofoil currently. And I was already speaking about that we changed the design of our foils, and here they are. Instead of building an entirely rotating foil, we chose to make foils with flaps. And these foils will change the lift that will be generated, and this will be done electronically. So they're electronically actuated, and we are currently working on a system that stabilizes our boat using an autonomous control system, which means our pilots should not have to change the angle of the foils themselves. It will just be done automatically. With the red part, we decided to close the open mechanism, the open rotating mechanism where our foils are attached to the struts. And this is made out of carbon, and together with the using flaps instead of fully rotating foils, we had a reduction of 30% drag in comparison with last year. After designing, we started building. And here on the slide you can see some of the materials we used as well as the problems we faced. And I want to highlight two here, starting with the water tightness challenge. Of course, when you have a boat, you want it to be watertight, and we had some issues with this in the past. So what we focus on is making sure our boat can handle water damage better, as well as we had a time issue. We're only with 7 full-time team members here, and 6 of them are in the technical team. So we really had to make sure that we spend our man hours efficiently, optimizing everything we can without taking on too much. And instead of only focusing on performance this year, we also wanted to have a closer look at eco-design, which is why we did research into using recycled filament for a 3D printer. When building our boat, we used 3D prints as well as making prototypes in 3D print. And currently we're with the university waiting until the extruder to make this filament will be finished. Also, we use electric-cooled dielectric coolant to cool our motor controller. This will heat up quite fast. And as you can see in the picture, our motor controller is in a reservoir of this coolant. And I'm not sure why you would even want to do it, but you can drink it if you like. Yes, so after these parts were finished with construction, we started testing. And one of the tests we did is with the resistance. We put a current through it, and what it does is over time it will heat up. And we did this test twice. Once just using this resistance and the currents, and the second is with adding PCM. And as you can see in the big graph, the resistance with the PCM cooled better, so it heated up less. So you might be wondering, what is this PCM? It's a phase-changing material, and it is like a candle wax-like structure. So what it does, when the battery heats up while using it, the PCM melts and therefore takes up the heat inside our battery. We don't need an external power source for this, so it's a passive cooling. You just pour it between the battery cells, as you can see in the picture, and this will take up the heat from the battery. What it does and why we chose to use it is that it spreads the peak heat loads inside our battery, and that will prolong our battery life. And we see several industrial applications. We see that producing such a battery is quite polluting. So if you can prolong your battery life, this is really something we want to do. So I said we wanted to have a closer look at our eco-design, and this we also did with our life cycle assessments. We, as a team, focused on the durability of our boat. We really wanted to last longer, as well as that we had a closer look at the reuse and destination of our former parts. We're not the only student team in Enschede, there are more, and one of them is the solar car. So what we did is that we gave them our old solar cells so that they can do research about the influence of lamination on solar cells. We also got our boat in various educational displays as a sign to promote sustainability as well as innovation. And we also partnered up and helped our high school team. They are called Young Solar Bootenten, who successfully competed in their first Young Solar Boat, Young Solar Challenge competition last weekend. And because we focused on the durability of our boat, this current boat that's in the paddocks will be a platform for testing and developing new ideas next year. So, what makes my team unique? Well, the fun fact is, right before we left, I was reading a certain book and I realized it's not about being unique or special. It's about the fact that we work together as a team and have this down-to-earth problem-solving mindset, as well as the fact that I, as a team manager, can say, without any one of my team members here, I would not be presenting to you today. Thank you.
Thanks for your presentation, jury members. Have you any questions?
Congratulations and thank you. Could you, personally not very familiar with PCM content, so my question might be a bit basic, but what's the materials including in that product there?
I think it's a product itself, so it's called phase changing material. It's like candle wax. I can put the slide up if you want, but I had some issues during the presentation. No, it's the one before. Yes. So what you do is you just pour it. You have to heat it up because otherwise it's solid, and then it gets into the battery between the battery cells, and then it's just like candle wax. It's the material itself.
What are the molecules? What's the material itself?
Ooh, I can ask my engineer for that up to the stage. Lenske?
The question was, what is exactly the materials?
You can have the microphone about materials.
To be honest, I don't know exactly, but it's some kind of, if I believe, it's some kind of salt structure. It smells kind of vinegary. Yeah. The temperature of the, well, the thing is you can change the molecular structure so it changes the temperature which it melts at. So for example, we chose a PCM that is, I think it melts around 40 degrees and it will be totally melted at 48 degrees. So for us that it's really to avoid our battery to get to the peak load, so the peak temperature, we don't want to reach it. But we've been in contact with the company. They can make it into any temperature range we wanted. So for example, I study also technical medicine, so it's an entirely different field, but they also use this product, for example, to keep nutritional stuff for the neonatal babies with this PCM at like a constant temperature. So it's depending on the structure of the actual PCM, you can change at which temperature it will work the best.
Yeah, and you can see it here in the graph. I'm sorry if I overtake, because then there's some kind of turning point within the graph, and that's the melting point. After that, it will just heat up, and instead of heating up more, as you might expect, because it's hot, it will just heat up at a normal pace again.
So you can also put it in your ceiling, for example. So if it gets really hot in the summer, then of course heat rises, and then the PCM in the ceiling can absorb the heat. So you don't need, for example, airco, but the PCM will take away the heat. And overnight, of course, everything cools down. So the PCM will cool down as well. And tomorrow it will be ready to absorb the heat of the day again. That's kind of the principle of the PCM.
Another question for the jury members? Yes, Jeremy Lagarig, jury chairman.
One last question, because what you have done, in fact, that's the aim of the event. In fact, we are looking for the efficiency, but if we want to be efficient, we need to be efficient on the water as a result, but we need also to be efficient as an engineers. And you just came out about, okay, we have to do with what we had. We had the spare parts from the previous year. We have just a limited amount of people due to the situation. So we cannot do the same as we achieved. So I am a bit interested about the result you achieved today. And if you can maybe share with your other team this experience about what, if you have to redo it another time, if you would have changed the order of priority due to the experience you had in the last year.
So the question is, let me repeat it to make sure I have it right, is that it's about what we would have done differently if we had more people on the team?
No. My question is 2-1. You say that you had to replace and you was not able to do everything you wanted. So I am a bit, I'm sure I will be well surprised from the result you had today. What was your result on the water today?
Our issue, you mean?
No, your result.
Oh, our result. We came in 8th, I believe.
Okay, which is quite very good.
Sorry?
Which is good.
I think
No?
we're not really happy with the results, to be honest, but it was the best we could do today.
Okay, and the second one is if you have to redo the year, would you have changed your priority in between, maybe using some parts from the past, that's something stupid, we need to reconstruct it. What would you have changed on this year?
I think if I could do it over again, I would have set stricter deadlines for the technical team to ensure we had more time during our testing period. So that's what we're doing actually next year. The 20th of July, we will have a meeting about stricter deadlines and what to make as a priority. So I think that would be it, because if we had more time at the end, we would have been performing better. But I think that's for all the teams the same. So
Yeah, but this is very highlighting a point which is very important as a student structure, but also in all the companies, it is mandatory to really upload all the data, to upload and to explain very the organization of the team. And it is very curious to see the difference in between some Latin team, which come with very smart ideas, but when the people leave, everything leaves with them. We have just that with the Swiss team a few minutes ago. And when we have some Dutch team, the first slide is the organization of the project. So we are definitely seeing two different approach, and I think that's something very important. And if you want to help your school in the future, you should at least upload all these data to help them to have the result. Okay. Thank you and congratulations.
Thanks. Applause for SolarBot 20, and I confirm 8th position. Après les qualifications du jour, that's finished for the Tech Talks today. Thank you, everybody. Thanks again. And now a few information about the
job dating.
The job dating with you, Charlotte.
We just wanted to share, usually we did 2 years ago a job dating allowing the students to meet the industry. And since we cannot really do it in that format this year, we're just going to be posting on this slideshow some openings to some of the organizations who are present here today. So if you are interested in those positions, feel free to go and speak to them under the tent, or if they're an exhibitor in the exhibition room, they are currently hiring, whether it's for internship or actually actual positions. So I'll just quickly present. So we have La Neva, that is in the OpenSea class. They're currently looking for electrical engineer and software engineer. So it's your chance to come and work in Monaco. That could be fun. Here at the Yacht Club, we are also actually looking for an intern to follow on the construction of our community boat. So again, if you want to come and have fun with us, please feel free to join us. There is Deep Speed, who has quite a number of positions that they are looking for. Certification manager, control engineer junior, electric powertrain system integrator, electric engineer junior, test engineer, mechanical engineer, and project manager. And finally, but not the last, Energy Observer is looking for a material engineer, an EO dev, a mechanical engineer, and a system engineer. So please feel free to go and speak to Jeremy and try to get an internship or a job with him. I know he's waiting for you. So that's all for now. If there is other companies who are interested to voice their openings, please come and see us and we will share it with the students. Thank you.
Thanks, Charlotte Mill, for this job dating information. And
we all have to say a big thank you to Charlotte for the amazing organization. Bravo, Charlotte.
Thanks for your applause. And you know that tomorrow, briefing for drivers at 8, and then there is some races, at 9. Thanks again.